Okay, my expectation is that you do or attempt each problem first. Then you use this video to check your answer. Okay? So, number 1. Here we go. First thing, we need to identify the variables and the question. So, every number, write it down. 2.0 hours, 37.8 kilometers south. Okay? And any other numbers? I don't see any others. And then that's step 1. Step 2 is going to be the question. What is the question? Oh, sorry. Back up. Hours. What are we measuring? Hours measures time. 37.8 kilometers south. We're measuring displacement. Okay? Question. Now, what is the question asking us to solve for? What is the average velocity? So velocity is the question. Step 1 and 2 are done. Step 3, pick your formula. Well, for formula, we have a formula that is velocity is equal to the displacement divided by the time. And we also have speed is equal to the distance divided by the time. Well, right here we have displacement, we want velocity. Here's the formula we're going to use. Velocity equals the displacement divided by the time. Now ask yourself, velocity, for step 4, do we need to rearrange the formula? If velocity is the question, do we need to rearrange the formula? No, we don't, because this formula is set up to solve for velocity. So we can skip step 4. Step 5, plug in. So velocity is equal to, so we're going to do substitution. Instead of delta D, we write down 37.8 kilometers. Instead of T, we write down 2.0 hours. And now we know exactly what we're going to plug into the calculator. So 37.8 divided by 2.0. Calculator says 18.9. So my calculator says 18.9. Now, significant figures. Original numbers, this one has 2 sig figs, this one has 3 sig figs. The smaller is 2, so our answer should only have 2 sig figs. So we got to round this number to 2 sig figs. We have the 1 and the 8. The 9, is it going to round the 8 up or leave it alone? Rounds it up. So our answer is going to be 19, 2 sig figs. Units of measure, okay, velocity and speed, it's either meters per second or it's kilometers per hour for our units of measure. So which one it is depends upon the information we have. In step 5, how we wrote down right there, our units of measure, kilometers per hour. Now, is your answer complete? Well, go back. It's asking for velocity. Velocity has direction. So we need to know what direction is going to have a complete answer. South. Now, that is the complete and correct answer. Number 2. We have 5.1 kilometers. And we've got, east. And we have 45 minutes. Kilometers east is displacement. Minutes is time. And the question is asking us to solve for velocity. Okay, formula for velocity is displacement divided by time. If velocity is the question, I do not need to rearrange the formula. Now, when we get here and we start plugging things in, before we get there, hopefully this jumps out at you. Okay? Our 45 minutes. We don't do minutes in physics. So, looking at fractions of an hour. 45 minutes, 3/4 of an hour, 0.75. So we need this to go from minutes to hours. 45 minutes, 0.75 hours. That's what we're going to put into the formula. So velocity is going to be the displacement, 5.1 kilometers, divided by 0.75 hours. Now we know what to type into the calculator. 5.1 divided by 0.75. We get, calculator says 6.8. Calculator says 6.8. Significant figures. I'm recording. 6.8. Two significant figures in our original number of 5.1. Two significant figures in our original number 45, which is still 75, so that's both two sig figs. So our answer should have two sig figs. 6.8, it already gave us two sig figs. How convenient, we don't have to do any rounding. So 6.8. Units of measure, okay, it's got to be meters per second or kilometers per hour because velocity is the question. Velocity is the question, so meters per second or kilometers per hour. Go back to step 5, kilometers per hour. Now, here's a helpful catch. When you're paying attention to your units of measure, if you had gotten kilometers per minute and you put the 45 minutes in, that helps you jump out and go, wait a second, I'm supposed to convert it to hours. So that, paying attention to units of measure by writing it here, helps you prevent from making the mistake by using minutes when you should have used hours. All right, so back to our question is asking for velocity. 6.8 kilometers per hour is not quite complete. We still need to include the direction east. Question number 3. Semi-truck drove 135 kilometers, dropped off its trailer, picked up another trailer, and drove back to where it came from. If its trip took 5 hours and 15 minutes, what was the average speed? So every number, 135 kilometers, 5 hours, 15 minutes. Okay, so 5 hours, 15 minutes, that's time. Hopefully that jumps out at you that we have to do a conversion there. Okay, so go to your time conversions. We do hours or we do seconds. Since we're dealing with kilometers, we want our time in hours. So that 15 minutes is 0.25 of an hour. So that is actually 5.25 hours. Okay, now this one, be sure you read the question carefully, okay? The truck started at like position A, town A, drove 135 kilometers to town B, all right? Switched trailers, and then it drove back. So how far did it really travel? Well, 135 there, 135 back. We have to add those together because the 5 hours, 25 minutes was the there and back. So a total of 270. Decimal point after that 0 because it is a significant figure, that 0, kilometers. All right, now the question is asking for the speed, average speed. So fortunately with speed, direction doesn't matter. So whether that was going east or west or north or south, the direction doesn't matter, so speed is good. So this is measuring our distance. So speed is distance divided by time. All right. If speed is the question, do I need to rearrange my formula? No, I do not. The formula is already solving for speed. So plugging in numbers, speed is equal to, do our substitution instead of the D, 270 kilometers. The T, 5.25 hours. Now we're going to punch that into the calculator. 270 divided by 5.25. And we get 51.42, blah, 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 blah. So calculator says 51.42857, whatever. Okay. Significant figures to our original numbers. We've got 3 sig figs there. We've got 3 sig figs, so 3 significant figures. The 5, the 1, the 4, and then ask yourself if the 2's go around the 4 up. It does not. So 51.4. Okay? Again, we were solving for speed. Speed's the question. So it's either going to be kilometers per hour or meters per second. Right here in step 5, we can see it's kilometers per hour. Because it's speed, no direction. So we don't have to add direction in there. Number 4. We have a truck that traveled 45 kilometers north, stopped for gas, and then traveled another 85 kilometers north. If the whole trip took 2 hours and 20 minutes, what was the average velocity for the trip? Okay? So we have 45 kilometers north and 85 kilometers north. Well, they're both going the same direction, so we can just add those up, vector addition. 45 plus 85 gives us 130. Significant figures, that is a significant figure. Kilometers north, that's measuring displacement. Okay? 2 hours, 20 minutes. Okay, that's going to be, conversion here, 20 minutes is 1/3 of an hour, so 0.3333. So we have 2.33333 hours. Okay, that is measuring our time. So we've got displacement and we have time. The question is asking for velocity. Formula for velocity is the displacement divided by the time. Do we need to rearrange the formula? No, we do not, because the formula is already set up to solve for what we're asking, what we want. So plug in numbers. Velocity is displacement. So replace the displacement with the 130 kilometers divided by the time of 2.333 hours. Okay? So put that in your calculator. 130 divided by 2.3333. Significant figures. Calculator says 55.71508, blah, 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 blah. So, significant figures. All right, with our time, the 2.33333 has unlimited significant figures. So that one does not determine the significant figures. This one will, the 130. Okay, so when we're adding, we count, we look at the places, we have the one's place is a significant figure, so even if it goes to 0, it is a sig fig. So 3 significant figures for our answer. Looking at the 5, the 7, the 1, ask yourself, is the 1 going around the 7 up? That is a no. So 55.7, all right? Units of measure, either meters per second or kilometers per hour for velocity. Looking at step 5, we can see it is kilometers per hour. Because it is velocity, we do need direction. The car was traveling north and then north and then north, so north is my direction. That's question number 4. On to the backside. Number 5. We have a cross-country athlete who ran 782 meters, and it did that in 4 minutes and 32 seconds. All right, meters. We're going with a distance here. Minutes and seconds, we have time. Now, hopefully that jumps out at you, that minutes and seconds. We don't do minutes in physics, so we have to convert this. All right, we've got 4 minutes. We've got 60 seconds in each minute. So 4 times 60, and then you're going to add 32 more. We get a total of 272 seconds. Okay, question is asking for speed. We've got distance, time, and speed. Formula, speed is distance over time. Speed is my question, so I do not need to rearrange the formula. Plugging in numbers here. So doing substitution, distance, instead of writing the D, 782 meters. Divided by, instead of T, the 272 seconds. So 782 divided by 272 gives us, calculator says, 2.875. Significant figures. We've got 3 significant figures in both of our original numbers. So 3 significant figures, the 2, the 8, and the 7. Ask yourself, does the 5 round the 7 up? Yes, it does. So now it's going to be 2.88, And units of measure for speed and velocity are kilometers per hour or meters per second. Here in step 5, we can see we got meters in seconds, so we have meters per second. Because it's speed, there's no direction. Number 6. We have a cheetah's speed measured at 35 meters per second. And it ran for 1 minute and 8 seconds. And meters per second, that's a speed. Minutes and seconds, we're dealing with time. Hopefully that jumps out at you. Minutes, we don't do minutes in physics. 60 seconds in a minute plus 8 more seconds gives us 68 seconds. And then the question is asking for how far? How far is a question of distance. We have speed, time, and distance. Formula that has all those in it is speed is distance divided by time. Distance is the question, so do we need to rearrange the formula? Yes, we do. So, magic triangle. Okay? Plug this formula into the triangle. See how D is above T in the formula? We need D to be above T in the triangle. And then we just leave S in the empty spot. Okay? So, if distance is the question, write down what I want. D equals. That's what I want to know. D equals. Take your pinky, cover the D in the triangle. S and T are side by side in the triangle, so put them side by side in the formula. We just rearrange the formula. Distance is the speed multiplied by the time. So now we can plug in, do some substitution. D equals, instead of S, we're going to write 35. Multiplied by, instead of T, we're going to write the 68 seconds. All right, so this was meters per second, and this was seconds. 35 multiplied by 68. We get 2,380. Calculator says 2,380. Significant figures. This has 2 sig figs, that has 2 sig figs. So our answer should only have 2 sig figs. This number has 3. It needs to have only 2. So look at the 2 and the 3. And ask yourself, does the 8 round it up? Yes, it does. So that 3 is going to become a 4. So we've got 2, 4, but 24 is not anywhere near 2,380, but 2,400 is. Those zeros are necessary placeholders, but they're not significant figures because there's no decimal point. So don't write in the decimal point, and there you have just 2 significant figures, the 2 and the 4, and a number that's close to 2,380 rounded. All right? Units of measure, we were solving for distance. We've been dealing with meters and seconds, so our distance is going to be in meters. There we go. Distance, so it doesn't have direction, so there we go. All right, number 7. A snail travels at an average speed of 0.025 meters per second. It's slow. It's a snail. Not very surprising. All right, and then it asks how much time will it take the snail to travel 1.0 meters. So 1.0 meters. So meters per second, that's the speed. Meters is the distance. Question is asking for how much time. All right? Choose your formula. I need a formula that has S, D, and T in it. Speed is distance divided by time. So, do we need to rearrange the formula? Well, T is my question. Do we need to rearrange it? Yes, we do. So our triangle, plug your formula into the triangle. D, magic triangle, D is over T in the formula. So I need D over T in the triangle. S in the empty spot. Time is what I'm looking for, so time equals, write down time equals, then cover the T with your pinky, D over S. D over S. So time is distance divided by speed. That's your rearranged formula. So go ahead and plug in. Time equals, replace, do some substitution. Distance, put 1.0 meters. For this S, speed, 0.025 meters per second. Punch that in the calculator. 1 divided by 0.025. Calculator says 40. All right, significant figures. Go back to your original numbers. This has 2 significant figures. This has 2 significant figures. So our answer should have 2 significant figures. All right, so 40, as that's written right there, has only 1 significant figure. So it looks like it has 2 significant figures. So it has 2 significant figures, we have to put the decimal point in. Now it has 2 sig figs. We were solving for time, okay? So time, it's either going to be, you have to go back to here, so we got meters per second and seconds. So seconds is going to be our measurement of time. On to question number 8. Car travels for 45 minutes with an average velocity of 26 kilometers per hour. Okay, minutes is measuring time, kilometers per hour is measuring speed. All right, it says velocity, but it's not giving me direction. So, and then the question, how far will it go? It's asking for distance. Hopefully this jumps out at you, the 45 minutes. We don't do minutes in physics, so that needs to be converted. 45 minutes, 0.75 of an hour. So we converted that into hours, from minutes to hours. Choose your formula. I need a formula that has time, speed, and distance in it. So speed is distance divided by time. Step 4, do I need to rearrange the formula? Well, distance is my question, so do I need to rearrange the formula? Yes, I do. Magic triangle. So D is over T in the formula, so I need D over T in the triangle. Put S in the empty spot. The question is distance, so write D equals. Cover the D with your pinky in the triangle. S and T are side by side, so S multiplied by T. Now we're going to go and do step 5. Plug in your number, substitution. So instead of S, we write 26. Multiplied by, instead of T, we're going to put the 0.75. This was kilometers per hour, and this is in hours. Okay, so in your calculator, 26 multiplied by 0.75. You get, calculator says 19.5. Go back to your original numbers, significant figures. We've got 2 sig figs here, we've got 2 sig figs here. So my answer should only have 2 sig figs. Okay, so the 1 and the 9, does the 5 go around the 9 up? Yes, it does. It rounds it up to 20. But the number 20 only has 1 significant figure as is drawn here, so you have to put in the decimal point so we can see 2 sig figs. Distance is the question, so units of measure for distance. Well, I'll come back to here. We're dealing with kilometers per hour, so kilometers is the distance traveled. Last question, number 9. Humans' average walking speed is 1.20 kilometers per hour. How long will it take to walk a distance of 3.30 kilometers? So every number, 1.20 kilometers per hour. 3.30 kilometers. Kilometers per hour is measuring a speed. Kilometers is measuring a distance. Question is asking for time. So formula has speed, distance, and time in it. S equals D over T. All right, do I need to rearrange my formula? Well, if T is the question, does it need to be rearranged? Yes, it does. So magic triangle. D is over T in the formula, so I need D over T in the triangle. S in the empty spot. T equals, cover the T with your pinky, and you end up with D over S. All right, so plug your numbers in. T is equal to, substitution, instead of D, we're going to put 3.30 kilometers divided by s. Instead of s, we're going to put in 1.20 kilometers per hour. 3.30 divided by 1.20. Calculator says 2.75. Back to original numbers for sig figs. We got 1, 2, 3. That last 0 is significant because it's at the end of the number and after the decimal. Same with this 3 on the 3.3. Sorry, 0 on this 3.30. At the end of the number and after the decimal. So both of those have 3 significant figures. Our answer needs 3 significant figures. The calculator gave us 3 significant figures, so conveniently we do not have to round. 2.75. We are solving for time. Time is either in seconds or hours, so come over to here. We've got kilometers per hour. We're dealing with hours, so hours is my unit of measure for time. And that is the practice worksheet for speed and velocity.